Hello everyone, my name is Joe Teston and I will be presenting plumbing basics and water supply. So getting started, we'll talk about how water relates to our planet. And our planet is almost completely covered by water, but not all of that water is available to us. Most of the water on Earth is either trapped under the surface of the Earth, frozen in ice caps, or comes in the form of salt water in our oceans and seas. And the water in our oceans also contains a high number of TDS, which means total dissolved solids, and it's just at a level that's way too high for human consumption. And a very small percentage of the water on Earth is actually fresh water, but throughout time, humanity has found a lot of creative and innovative ways to harvest fresh water, from gathering and filtration of rainwater, to digging or drilling of wells to obtain water from under the Earth's surface, and even solar distillation. But nonetheless, precipitation plays a huge role in the process of obtaining fresh water and using it to benefit us in a lot of ways and benefit our survival. So this brings us to the geologic cycle. And this is something that I would assume most of us have definitely heard of by now. We learned about it in grade school a good bit. Essentially, it's the process of water from the Earth's surface being evaporated into the atmosphere, being condensed from a vapor gas back into a liquid form, and precipitated down to the Earth's surface in the form of rainwater. And modern water supplies, how most of us get our drinking water and water that we use for anything, comes from rainwater, groundwater, which we would use wells to drive, bore, or drill into the earth, into aquifers to obtain water, and solar distillation. So wells can be drilled or dug and use pressure to draw fresh water from aquifers. And then solar distillation is a process used mostly in remote areas where there's a limited access to fresh water. It's a really simple process that involves evaporation and condensation. And essentially there are black bottomed vessels filled with water and topped with clear glass or plastic. And then sunlight gets absorbed by that black material and speeds up the rate of evaporation. And the evaporation is then trapped by the clear topping and is funneled away. But most pollutants do not evaporate, so they're left behind. And most stills for solar distillation would need to be about 6 square meters in size, just to produce enough water for a single person for a day. But so you would need multiple solar distillation systems to produce a large enough quantity of distilled water. But it's a relatively low maintenance method, and it doesn't require any energy costs or moving parts, so it can be effective in some ways. Rainwater is one of the purest available sources of water. It's slightly acidic, but a small amount of buffering can neutralize the acid, and therefore it can be used as a clean and reliable source of fresh water if it is captured and treated properly. Most of the rainwater that falls to the ground infiltrates deep beneath the roots and percolates through rocks and soil to form an underground water. These underground reservoirs are called aquifers, and they provide a significant quantity of water. The upper level of an aquifer is called the water table, and the impermeable rock layer beneath that is called an aquiclude. And water obtained from aquifers by drilling wells requires less elaborate treatment because it's relatively pure after it gets filtered through the Earth's crust. Groundwater can be depleted if we use it at a faster rate than it can replenish itself. So wells can be drilled into the aquifers and water can be pumped out. but precipitation eventually adds water, sort of recharges water into the porous rock of the aquifer. And the rate of recharge is not the same for all aquifers, though, and that's got to be considered when you're pumping water from a well. Groundwater is water that has infiltrated the ground to fill the spaces between sediments and cracks in rock, and it is fed by precipitation and can resurface to replenish streams, rivers, and lakes. But groundwater can become contaminated when an excessive number of pesticides and herbicides are sprayed, like specifically that would be in agricultural fields. You can have septic tanks leak, and landfills are improperly managed and toxic materials seep through the soil into the aquifer. All that being said, groundwater is important because it provides drinking water for over 50% of the US population, including almost like 100% of the entire rural United States population. But it's also used for domestic, industrial, and commercial purposes, and a lot of the irrigation for farmlands. As we learned earlier in the semester, in one of the first modules, the Romans were the original architects for the plumbing systems that we use today. And technically the Egyptians built aqueducts before the Romans, but it was the Romans who created complex structures on a large scale that were able to use gravity and the natural slope of the land to transport fresh water from distant places into heavily populated urban areas so that they could be used for clean drinking water, fountains, and even baths. Modern plumbing systems are very, very similar, but they use a lot more pressure. They use pipes that supply water to your house, and they get their water from one or two sources. It's either city water or well water. And if you live in an established residential area in a city or a suburb, most likely your system uses city water. My system is city water. Most people you know most likely is city water unless you're in a very rural area, but essentially a series of large pipes called mains are buried throughout your neighborhood, typically under the street. And from the mains, individual lines branch off to supply your house and businesses located on the system. But before entering your house's plumbing system, the water will flow through a water meter. And the water meter measures the amount of water used in your house so that the local utility system can bill you for how much you consume. And you can find a shutoff valve located at the water meter, and that's usually near the street. You can completely shut off the water to your house with that valve, and it's very useful in the event of an emergency like a broken pipe or something like that. So well water systems actually have a lot of advantages of their own. You wouldn't have to pay any monthly water bills. The water is chemical free, and you have a lot more freedom from water restrictions, like if the area were to ever be under some sort of drought, you would have your own sort of like self-sustaining water aquifer. And typically it increases your property value too. To have something like that, it's very valuable. And water comes into your home, so obviously it has to come back out. And that's where the drain portion of your plumbing comes in. Your drains rely on gravity to take the wastewater away from your home and send it off to either a municipal wastewater place or a septic field. And that sounds pretty simple, but there really are three important parts of your drain system that you should know about. And those are vents, traps, and cleanouts. So we don't need to get into the specifics for exactly how each one works, but without vents, your drain pipes won't work properly. Drains have to have proper venting to allow wastewater to flow through the system. Okay, and then traps are the curved sections of the pipe found beneath your sink, right here, built into the base of your toilet under your kitchen sink. So water always stays in the trap, but and it prevents sewer gas from backing up into your house. So those are really important. And then obviously sewer cleanouts over here. In the event of your sewer system backing up or anything, it's usually in somewhere you can find it in your yard, and it will allow you to jet the line or something like that. And that brings us to and this is going to explain essentially how sewer systems work. Sewer systems are vitally essential to modern plumbing, and every single time you flush a toilet or you use your sink or you take a shower, you are creating liquid waste that contains deadly bacteria and has to be transported and treated. And in ideal conditions, a sewer system will flow downhill through a sewer main line using gravity, and it will travel to a sewage treatment plant. Wastewater contains a lot of solids, which can make it hard to pump. Not to mention you can create deadly gases like hydrogen sulfide when you pump waste. But sewer mains in large areas are usually 3 to 5 feet in diameter, and sewer mains will flow into larger and larger pipes until eventually they reach a wastewater treatment plant. Now, usually wastewater treatment plants are in low-lying areas, which makes the engineer's job designing them much easier. However, if your house is actually below the elevation of the treatment facility or needs to travel uphill or over a hill or through mountains or anything like that, you would have to use a grinder pump or a lift station. A lift station essentially pumps sewage from low elevations up to the sewage main line so they can continue out and into the wastewater treatment facility. And these pumps are specifically designed to handle large amounts of solids like waste or toilet paper or flushable wipes. And lift stations tend to produce hydrogen sulfide, like I mentioned earlier, and sometimes they can even explode. So they're typically kept as far from populated areas as possible, not to mention they'll create a sort of a pungent smell as well. And while lift stations are important, the essential thing to remember is that gravity does most of the work and makes up most sewer systems. Pressure is involved in a lot of parts of plumbing, but overall, gravity is the most vital and important part of modern plumbing. And like I mentioned earlier, the Romans were sort of the ones who originally designed that system, and it's pretty incredible that's the system that we're still using today and sort of building on that. And that is the entire presentation. So thank you guys very much, and I hope you enjoyed it.